Hello everyone. In this video, we are going to discuss about one of the simplest sorting algorithms, that is bubble sort algorithm. We will learn about the logic, implementation and efficiency of that algorithm in this video. Let's see the definition of that bubble sort algorithm. Bubble sort is nothing but a sorting algorithm which starts from the first element of an array and compares it with the second element. If the first element is greater than the second, we swap them. It continues this process until the end of the array, that is, until the array of the elements gets sorted with the largest elements bubbling to the top. So basically, bubble sort is a comparison based sorting algorithm which repeatedly swaps the adjacent elements if they are in the wrong order. It's called bubble sort because smaller elements gradually bubble up to their correct position. Let us see a simple example on the implementation of bubble sort algorithm. Initially, we have an unsorted array of elements which contains elements in the order 5, 3, 8, 4 and 6. We know the basic logic of bubble sort algorithm. What is that? If the first element is greater than the second element, we swap the first and the second element. In this example, we are going to sort the given array in ascending order. We can see that in step 1, we are comparing the first two elements of the array, that is 5 and 3. In this case, 5 is greater than 3, so we have to swap these two elements. On to the next step, we are comparing 5 and 8. 5 is less than 8, so no swap is needed in this step. On to the next step, we are comparing 8 and 4. 8 is greater than 4, so we need to swap these two elements. On to the next step, we are comparing 8 and 6. 8 is greater than 6, so we need to swap these two elements also. On to the next step, we get a final sorted array of this example. And we can conclude that no more swaps are required after this step. Thus, we get the final sorted array of our example. Let's have a look at the code snippet of our bubble sort algorithm. Here we define a function named bubble sort which takes an array and its size as input. Here we are declaring three integer variables I and j for our loops and temp variable to swap the elements when needed. Here we have initialized swap, which is a flag variable which helps us to optimize the algorithm if no swap occurs during a full pass, which helps us to stop the sorting early because the array is already sorted. The outer for loop runs n-1 times because in the worst case we need that many passes to fully sort the array. Before every pass, we reset the swapped flag to 0. If no swaps happen, it means the array is already sorted and we can exit early. The inner for loop goes from 0 to n-I-1 because after each pass, the largest element moves to the end, so that we don't need to check it again. The if condition compares the first two adjacent elements of the array. If the array of j is greater than array of j plus 1, it means they are out of order and need to be swapped up. We need to swap the two elements using a temporary variable. This swapping pushes the largest element to the right. Since we swapped elements, we set swapped is equal to 1. The last if condition checks if swapped is equal to 0 after a full pass, it means the array is already sorted and we break out of the loop early. In best case complexity, we get O of n. Why is it O of n? In the first pass, we perform n-1 comparisons. No swaps occur because the array is already sorted. The algorithm detects this and stops early. Bubble sort algorithm is slow in worst case complexity. In the first pass, we do n-1 comparisons and swap them, and in the second pass, we do n-2 comparisons and swap them, and in the third pass, n-3 comparisons, and in the last pass, we do one comparison. So, the total number of comparisons is n into n-1 by 2, which simplifies to O of n square. In average case complexity, the array elements are in random order, which means the array is halfway sorted to its correct position. So in this case, the total comparisons will be n into n-1 by 4, which is also equivalent to O of n square. Thus, we have discussed the logic, implementation and complexity of this bubble sort algorithm. Thank you.